In the third week of development, an embryo, called gastrulation moment, first converts the bilaminar embryonic disc into trilaminar embryonic disc, which consists of ectoderm, mesoderm, and endoderm. This process is called gastrulation. At about 50 days after fertilization, on the surface of the epiblast of the bilaminar embryonic disc, a thickened band appears caudally, called primitive streak. It defines the body axis afterward, including cranial and caudal end. This phenomenon is called directionality. On the cranial end, the primitive streak extends to form a primitive node, and at a primitive node, epiblast invaginate to form primitive pit. The pit with its elongation toward the caudal end forms primitive groove. Through the primitive pit and groove, the epiblast cells invaginate inward and first replace the hypoblast cells underneath, which form definitive endoderm. The epiblast cells remain in their original place, form ectoderm, and then some of the invaginated epiblast cell remains in the space between ectoderm and endoderm, form mesenchyme. Some of them later form intraembryonic mesoderm. Mesenchymal cells from the primitive node and pit migrates and form notochordal process on the cranial end, which later elongated to form notochord. The primitive pit also extended into notochordal process and formed a notochordal canal. The notochord extends and stops at a precordial plate cranially, where ectoderm and endoderm are fused, which later forms oropharyngeal membrane. On the caudal end, notochord also stops at the cloacal membrane. On the ectoderm, some epithelial cells thicken and form neuroplate. The neuroectoderm later give rise to CNS. On the day 18, neuroplate invaginated to form neurogroove and neurofold. After the fold fused, the neurocrest and neurotube are also formed. The neurocrest cells on two sides will later undergo epithelial mesenchymal transition and migrate and differentiate into ganglia.